All right, let's get excited about writing functions today. All right, the first thing we're going to take a look at is how to use a table to write an equation. So a table will have an x value and a y value paired up as ordered pairs. What we're going to look to do is first determine a relationship between the x and the y values and then write an equation. So our first pairing is this 1 and this -2. So the thing we try to figure out is there a relationship between 1 and -2? Can we do something to the 1 to get to -2? And think about your different operations. Can I add something, subtract something, multiply by something, or divide by something to equal that -2? Okay, so I could subtract a 3. 1 minus 3 is equal to -2. So that works out. Once you find a relationship that works for one ordered pair, you have to test it on your other ordered pairs. So what we're testing out is, does subtracting 3 work? If you subtract 3 from all your x values, do you get the y value? So let's try with our next ordered pair, 2 and -1. So what can we do to the 2 to get to a -1? And we're trying to subtract 3 to see if that works. 2 minus 3. Is 2 minus 3 equal to -1? And it is. So let's run through that with our other ordered pairs just to make sure it works for everything. The next one we would try is that 3, 0 ordered pair. If you take the x value of 3, and again, we thought, hey, why don't we try to subtract 3? Is 3 minus 3, and we want to know, does it equal the y value of 0? 3 minus 3 is 0, so that one worked out. And then we're going to try our last ordered pair, that 4 and the 1. So we're starting with our x value. We're checking to see if we subtract 3, do we get the y value of 1? 4 minus 3 is 1, so it worked out. So our equation is going to be, we took our x value, the 1, 2, 3, and 4, and we subtracted 3 from it, and that gave us the y value. However, another way that we would write this, just more standard form for this, would be the y out front, so our y's are equal to all of your x's minus 3. So we lucked out. We got the relationship on the first try. Other things you could try, because it may not be, the first one, maybe multiplication. 1 times what number can get us -2? And you'd say, oh yeah, -2 works. So if you take your x value and multiply it by a -2, do you get the y value? So you try it on another ordered pair, because it worked on the first one. So the second ordered pair is 2 times -2, and now we're looking at this second ordered pair right here. Does that equal the -1y? Well, 2 times -2 is -4, which does not equal 1. So then we know that multiplying by -2 doesn't work. So sometimes you may try the one that works first, but if you have to go through some other ones first to get there, that's okay. You just have to find a relationship between your x and your y that works on every single ordered pair. So in our conversations about functions, we talk about input of a function, that's your domain. Output of a function is your range. Input of a function is going to be our independent variable. And the output of a function is what we call our dependent variable. Dependent. So what that's telling us is that whatever we put into our input affects the output, or the output depends upon what we put into our input. So let's go ahead and write this in our notes. I know it's kind of a lengthy sentence, but the value of the dependent variable depends on, or is a function of, the value of the independent variable. So that's the relationship between your independent and dependent variables. So we can apply this to some situations where we are identifying the independent and dependent variables. In the winter, more electricity is used when the temperature goes down and less is used when the temperature rises. So what we're saying is that the amount of electricity used depends upon what the temperature is. So when we have to say what the dependent, oops, what the dependent variable is, we're going to say that it's the amount of electricity and the independent variable is the temperature. I don't have the best little stylus right now, so my handwriting is really sloppy in these videos. So again, the amount of electricity used depends on the temperature. So the temperature is the independent variable. All right, cost of shipping a package is based on its weight. So our independent and dependent, so the cost of shipping a package is based on its weight. The cost of shipping a package depends on its weight. So the thing, the cost, here we go. I'm getting distracted by trying to find my markers. All right, so the independent variable is going to be the weight. And then depending on what the weight is, that will give you the cost. So the cost is dependent upon the weight. All right, the faster Ron walks, the quicker he gets home. So what that's saying is that the time it takes Ron to get home depends on the speed that he walks. So our independent variable is going to be the speed. That's the one that determines the time that he gets home. If he walks faster, he gets home sooner. If he walks slower, he gets home later.